Okay, now that we're wired up, let's get this CAN bus online. So I'm going to SSH into my Raspberry Pi 4, my Klipper. So I just set up a profile called vCore. So you'll have to know your own IP address, that sort of thing. You have to get into your RPi. So first things first, we need to set up the CAN 0 network. So this is the CAN bus, but it's implemented as a Linux network interface. So slash etc network. Now the instructions say to create a file called inside of this slash etc network interfaces.d can 0. So we need to type in this information or copy it out of the PDF. And the only issue is that didn't actually work. After rebooting, it still didn't come up. For some reason, the interfaces file was empty. But there was this backup file that was next to it, and we see that in this backup file, it actually sources all of the files in that interfaces.d directory. So for whatever reason, I don't know, under RADOS or something, the default interfaces config file, which normally would bring in all those interfaces.d file, was renamed and a blank one was put in place. So anyway, one way or another, you need to rename this interfaces.backup back to interfaces, or at least copy over that source directory interfaces.d in order to get that to bring up. Now, once you reboot, then when you go to ifconfig, then you'll see this CAN 0 network interface. Now with that, I would suggest installing, let's see, where was that? Oh yeah, install the CAN utils. That'll give you some utilities later on when you want to interact with CAN, but the next thing in the instructions was to query your that CAN bus and find out what the ID of your toolhead is. Now, right now, I haven't updated the firmware on the toolhead, so the toolhead's not answering. So we're coming back with 0 UIDs found. So at this point, we need to go over and go to the STM32. We need to download this STM32 programmer. Now this will depend on whether you're using Windows or Linux. In my case, I'm using Linux, but I'll show you both Windows instructions and Linux instructions. So I downloaded the archive. I ran that Linux, went through the install, no issues. I'm on Ubuntu 2004, and once I did that, I have the Cube programmer in my menu. So I'll bring that up. And okay, so with this open, let's, oh, we didn't compile our firmware file. Let's do that next. So back in Klipper here, we're going to go into the Klipper directory. So this is off the home into Klipper. So /home pi Klipper. And we need to do a make menu config. And this is going to compile the firmware that we need to program onto the toolhead. At some point in the future, this will probably be automatic, but for now, we got to set this up on our own. So instructions say we go into microcontroller architecture, we go down to STM32 processor model. Now this is where you're going to have to look on your toolhead. If you've got the new version 1.2, I think it is, which I have, you'll probably have an STM32G0B1, but just take a picture of your EBB toolhead, look at the chip, make sure that the model on that main CPU chip matches what you have here in the processor model. So it may be one of these other ones, but just confirm that. In this case, we're not using a bootloader. I'd like to have one on there, but I'll follow their instructions and we'll do it no bootloader style for now. 8 megahertz crystal, and in my case, since I've wired up the CAN bus, will be my normal communication for the toolhead. Then I'm going to select CAN bus on PB0/PB1. If you decide not to use CAN bus and you're going to wire USB between your Raspberry Pi and the toolhead when you're printing, then you go in here and you would go back up and select serial on, I think it is PD1110. So So with that, now notice the CAN speed, it was defaulted to 500K here. And I would like to do that, but the instructions were having it as 250. So we're going to change that. We'll go back to that network file. So sudo etc. network interfaces.d CAN 0. Yeah, why is that not etc. network interfaces CAN 0? I don't know. We need to change this to 500K. So bitrate 500K to match. Okay, so we'll save that and we'll reboot. And while that's rebooting, we'll give it a second. Okay, we're rebooted, so I need to go back into the Klipper directory. So we're in home PyClipper. Now, so we did the make menu config before. Now we actually need to run make. So you can run make clean if you want, and then run make. So now it's building the firmware file. We'll end up with a clipper.bin file, and we're going to have to copy that out of our Raspberry Pi, and then we need to program that with our STM32Cube programmer. To put the tool head into DFU mode, we're going to hold down this boot button while we hit the reset button. Then when it goes through its restart sequence, it's going to see that we've got the boot button down, and it's going to put the device into DFU mode, and we're going to be able to see that within the device manager, whether we're in Windows or using LSUSB in Linux. Okay, with that done, if we look at that out directory, we see our bin file. That's the one we're looking for. So I need to copy that out. So I'm going to use secure copy. You can, the instructions show using a graphical user interface, so you can do that if you want. So that file was in Klipper directory off the home directory. It's in out and clipper.bin. And I'm going to call that clipper dot, no, yeah, clipper.ebb.bin. Okay, so that's done. So if we look at the file, we see clipper.ebb.bin. Okay, so now we'll come over to our cube programmer. We'll open the file. Let's see, we're in the clipper.ebb.bin. Actually, that was the first file I did. So STM32. So there's the file that we just programmed. Okay, so it's loaded that up. That looks successful. Now, if we look over in serial number, we have no ST link detected. However, I know that, so what we do at this point is we go over to the toolhead and I'll show you how we're going to get the toolhead into DFU mode. All right, so toolhead is now, it's powered on and it's in DFU mode. If I come over in here and hit refresh, I'm still not getting an ST link detected. But if I do an LSUSB, I do see the STM device in DFU mode. So I'm not sure why that's not picking up that device right now. So I'm going to diagnose this and figure out how we're going to get this going. All right, this was easy. I had this ST link here. We need to drop down and select USB since we're not using an actual ST link programmer device. So once I do that, then we see the port and USB 1. We see our serial number and our PID and VID, which is going to match the PID and VID here, DF11 and so on. So that's good. And so we should be ready to download. Yeah, let's do it. Download. Erasing sectors, download in progress, and then we have a file download complete. So it looks like we're good. Now we should have our tool board online. All right, so I went over to the tool head and I hit the reset button. That way we get the tool head device out of the DFU mode. And so I did an LS USB. We now see that the STM device in DFU mode is gone. So we're no longer in DFU. And I should be able to log into the vCore now. Even though the USB is still connected, I should be able to see it. Yeah, there we go. So now I've got my, this is my CAN bus UID for the toolhead, and I'm ready to set up Klipper now. And I'm also running on 500K, which is good too. So in our EBB documentation under Klipper configuration, it gives us this link to the EBB page, and we can get our Klipper configuration from here. So under CAN version 1.1, which is what I have, the G0B1, and then we have two config files, version 1.2, which I'm pretty sure is what I have. We click on this, we'll see a Klipper config file. So we want to bring this over and just include this as part of our configuration. So we'll click on raw and we will save as. Yep, save it there. Then coming over here, we're in, yeah, here we are. There's that file. So sample Big Tree Tech EBB CAN bus. Copy that into our Klipper under the Klipper config directory, which is where the printer.conf file is. And now over here under Klipper config, there's our sample file. So I might as well rename that from sample to, just remove the sample part of it. We don't need that on there. All right, and I want to copy the name of that file. Go into printer.conf. Now I had everything set up previously with my own toolhead, which, so we have everything from the probe to the RGB to end stops and so on are all set up under that old format. So I got some work to do here. But here we go. Tool head, pick your extruder and hot end. So see, that's orbiter, input shaper. I think we should go right up to the top. Get all of this set up in early. So we have control board base set up, vCore 3 steppers. Yeah, I think we can go right about here. So we want include config printers, so it'll just be that. Big Tree Tech EBB toolhead. There we go. Now let's split screen. I want to see that file. We want to see all these pins and so on and how it's configured. So there's our CAN bus UID. We need to, I need to get that again because I lost it out of my clipboard. I need to copy that ID over, replace what's here. All right, now Klipper knows what to use. Serial. I don't know if this here is valid or not. Might be. Just make sure that that file exists. No. Well, that sucks. Dev serial by ID. Serial. I don't know about that. That doesn't look right. We may have to come back to that. Let's see. It should be CAN bus. Yeah, we should be using that. Let's see what our instructions say. Serial is instructed below. Klipper3D.org overview. All right, let me read up on this. Okay, I went through the EBB board configuration. I needed to change things like I'm using the Max 31865 chip that's on there. You may or may not have that. And then I'm using the PT1000, so I have to set these two numbers to 1000 and 4300 instead of the 100 and 430 they were at. Let's see. And then comment it out using just the ADC type thermistor. Now the RADOS already configures the orbiter's stepper and so on. So I needed to move the include for the Big Tree Tech EBB to come after the repeato and orbiter. That way the Big Tree Tech stuff is overriding that information. So it's, for example, overriding the step-dir enable pins for the extruder, and then I'm also commenting out stuff like rotation distance. I kept in microsteps, but that's not specified in the orbiter config, so this might actually be wrong. Let's see what else. Actually, yeah, I'm going to comment that out too. You just kind of have to look at both configurations and figure out what you want to override and what you don't, because this really is just a sample configuration. And then I kept in the fan and the heater fan and the TMC 229 extruder. So most of this stuff is also specified in the orbiter configuration. So I really just want to override this UART pin. They're setting the stealth chop threshold to, what is that, 900, almost a million. I'll keep that in there because I do kind of want that disabled. I assume that that's what that means. It's 0 in the orbiter configuration. So not sure whether I should keep that or not. And then down in the rest of my configuration, I'm just disabling any other information I have for extruder other than my PID values and my nozzle diameter. Disabled all this other stuff here, and disabled the fan and heater since that's now in the other configuration. And then I have to redo input shaping since I replaced the tool heads, so I commented that out. So should be good to go. I'm ready to restart Klipper and start testing out the tool head. Okay, I have the tool board running and reporting as a system within Klipper, and it's updating its CPU information. So there were a few little tricks that needed to be changed. So let's review the config file. All right, here we go. So inside of that sample configuration, it was overriding ADXL 345, but it wasn't specifying tool heads. So it basically looked like this. According to Mikkel I was able to search through history and find him saying that that doesn't work because it's overriding the default ADXL 345 config, and that's not allowed. So what he had suggested was you just put a name at the end here. You can call it whatever you want. I called it toolhead. We specify the CSS pin as EBB CAN PB12, which was there before. We don't use SPI bus in this case. The board itself, I guess, figures that out. And so with that saved, then in order to use that ADXL 345 chip in our resonance testing, we need to add that same name, the toolhead, after the ADXL 345. So that way we're in a way configuring a second ADXL 345. We won't bother using the one off of the Octopus board, but it doesn't overwrite that default config wherever that is. So once I had that running, I think that was about it. Then I have everything running there, and in our dashboard, I see the extruder reporting as 27.5 degrees, so we're good there. I'm ready to wire up the rest of it, and then we can start doing some resonance testing and maybe get to printing soon. Another thing that wasn't clear in the manual is that if you have the version of the board that has the max 31865 chip on it, then you want to use this header over here, whether you're using the PT100 or 1000. And you're going to set these dip switches based on this table, whether you have the PT100 or 1000. These switches are set by default, at least on mine, to PT100. So I had to change a few of these switches in order to get into PT1000 mode. Now, most of the time, your PT1000, you're just going to have the 2-wire um, thermistor. So you'll want to route those to the 2 middle pins. The 2 outer pins are going to be blank. If you don't have the 31865, then you're going to use this PT1000 header over here. And that was something that had confused me, is why does this say PT1000 over here if I know the chip is over in this area? So just keep that in mind. You're ignoring the PT1000 header over here if you're using the max chip. So this part of the manual is really important. You don't want to miss this one. So after going into DFU mode, the pin that controls the hot end MOSFET is actually the same pin that's involved in the DFU bootloader programming. So that pin goes high, it actually turns on the heater. So if you have wired up your hot end and you go to do your firmware upload, your heater's going to start. And it's just going to keep going. It's never going to stop. It's the thermistor is not being read. It's just that MOSFET's purely on. So you're going to burn out your hot end. They really shouldn't have used that pin, but I'm guessing they didn't find this out until afterwards, that that pin was also reserved for firmware upload. Anyway,